Grade 10. Hello, everybody, and welcome to our online series for mathematics with you, Mr. Ayman. First of all, uh, I would like to say some things. Please, everybody, stay at home, stay safe. Please wash your hand and your face maximum each 2 hours. God be with us to pass this period together without no losses to our beloved. So, without further ado, let's start. Algebra, Unit 1, the last lesson, the multiplicative inverse. So, in matrix, we studied before. We studied addition and subtraction. We studied multiplication and we studied determinants. We studied all three. How about matrix division? Does anybody consider why that there is no matrix division? The answer is simple. There is no matrix division, but first let me solve this arithmetic question. 6 divided by 3 equal to 2. That's correct. How about if we said 6 multiplied by 1 over 3? Still, the answer is 2. So 1 over 3 is simply the inverse of 3. So 1 over 3 is the inverse of 3. So I can say that there is no matrix division, but there is multiplicative inverse of the matrix. Okay, the definition of a multiplicative inverse. What's multiplicative inverse of 3 over 4? Simply, it's 4 over 3. Why? Because 3 over 4 multiplied by 4 over 3, the result will be equal to 1. So the definition of multiplicative inverse is two numbers multiplied by each other, the result will be 1. The same for matrix. From this point, I can say, if A is a square matrix, and let me notice that we only study this term 2 by 2 inverse matrix. So we get 2 by 2 inverse matrix, not 3 by 3, not 4 by 4, only 2 by 2. So if A is a 2 by 2 matrix, A is a 2 by 2 matrix. So A multiply its inverse, which denoted by A power to negative 1, the result will be 1. What is 1 in matrix? 1 in matrix, it's identity matrix. So simply, it's easy. A is a square matrix. What's its inverse? It's A power to negative 1. A times A power to negative 1, the result will be the identity matrix. The question now is how to find the multiplicative inverse. Again, we'll study only the multiplicative inverse of 2 by 2 matrix. Example: if A is this matrix and B is this matrix, prove that A is the multiplicative inverse of B. Simply, I need to prove that A and B are two multiplicative inverse matrices. So A multiply B, the result will be, yes, the identity matrix. Let's move on. Solution: you need to prove that A times B equal identity matrix. AB equal, so I need A multiply B, so matrix A multiplied by matrix B, row times column. We studied the multiplication, so 4 multiplied by negative half plus negative 2 multiplied by negative 3 over 2. Did I finish our columns? No, there are another column. So the same row times this column, 4 times 1 plus negative 2 times 2. So after we did our multiplication process, we get that negative 2 plus 3 equal to 1. 4 minus 4 equal to 0. Negative 3 over 2 plus 3 over 2 is 0. 3 plus negative 2 is 1. So we get our identity matrix. Therefore, A is the multiplicative inverse of B. Got it, everybody? Is something hard to understand? Please tell me. Let's move on. Example, or no, it's not an example, it's an illustration. How to find the inverse of 2 by 2 matrix. Let's assume that A equal A, B, C, D. So to find our inverse, A inverse equal 1 over a determinant of matrix A multiplied by. We will replace A with D and D with A. Again, we will replace A with D and D with A. And then we change the sign of B and C. So we replace A with D and change the sign of B and C. If B was negative, so it become positive. If B was positive, it become negative, and the same of C. So the inverse of matrix A equal 1 over a determinant multiply D negative B negative C A, D negative B negative C A. There is only one condition to exist or to existence of the inverse of the matrix, that the determinant cannot be equal to 0, because 1 over 0 is undefined. I would give us math error. So the only condition that I need to verify that any matrix, and I mean any matrix, has multiplicative inverse, that the determinant cannot be equal to 0. Okay, let's move on. Example, find the multiplicative inverse of matrix A. First, we need to calculate the determinant. Determinant is negative 2 multiplied negative 4 minus 2 multiplied by 3. Negative 2 multiplied negative 4 is equal to 8 minus 2 multiplied by 3 is equal to 6. 8 minus 6 is equal to 2. So our determinant will equal to 2. So multiplicative inverse of A is 1 over 2. Multiply our new matrix, we will replace negative 4 with negative 2. So negative 4 will be here and negative 2 will be here. And change the sign of 2 and 3. 2 is positive, so it becomes negative 2. 3 is also positive, so it becomes negative 3. And then we multiply half by negative 4, half by negative 2, and half by 3, negative 3, sorry, and half by negative 2. Let's see in a proper handwriting. Determinant of A, negative 4 multiply negative 2 minus 2 multiply 3, 8 is the result of negative 2 multiply negative 4, 6 is the result of 2 multiply 3, 8 minus 6 is equal to 2. So 1 over a determinant times, we will replace 4, negative 2 is 4, so negative 2 and 4 are replaced, and change the sign of 2 and 3. 2 will become negative 2 and 3 will become negative 3. Half multiplied by negative 4 give us negative 2. Half multiplied by negative 2 will give us negative 1. Half multiplied by negative 3 will give us negative 3 over 2, and half multiply negative 2 will give us negative 1. So our inverse matrix is negative 2, negative 1, negative 3 over 2, and negative 1. Got it, everybody? So let's move on. Find the real values of x, which makes matrix A has multiplicative inverse. I said earlier in this video that I have only one condition that make any matrix has multiplicative inverse, that the determinants cannot be equal to 0. So matrix A, x, 3, with 12, and x. So I need to find a real values of x to make A has multiplicative inverse. So how we calculate the multiplicative inverse? First we get the determinant, x multiply x minus 3 multiplied by 12. X multiply x is x power 2. 3 multiply 12 is 36. I need to prove, or I need to find the values of x that doesn't make the determinant equal to 0. In that case, matrix A will have an multiplicative inverse. Otherwise, if the determinant equal to 0, so matrix A doesn't have multiplicative inverse. So let's find out in a proper handwriting how this will be. Determinant of A, x multiply x minus 3 multiply 12. X multiply x minus 3 multiply 12. X multiply x is x power 2 minus 3 multiply 12 is 36. And we need to set our function or our equation to equal to 0. A has only matrix, has inverse if only and only if determinant of A doesn't equal to 0. So A has inverse if and only if a determinant doesn't equal to 0. So I need to find the values that make the determinant equal to 0 and neglect it. I don't need these values. So first we need to find the values of x that make the determinant equal to 0. Our determinant is x power 2 minus 36. So let's make it equal to 0. 36, x power 2 minus 36 equal to 0. 36 will go to the other side and change the sign. So x power 2 will equal to positive 36. So we take square root to both sides. So x will equal positive or negative 6. So all values make the determinant valid except these two values, positive or negative 6. These values makes our determinant equal to 0. So matrix A in that case will not have an inverse, because our determinant will equal to 0 if x equal to 6 or x equal to negative 6. So A has inverse if and only if x not equal to 6 or negative 6. So x equal all real numbers, difference, but 6 and negative 6. All real numbers are okay, but 6 and negative 6 is not okay. Let's move on. Please pause the video and start solving this one. A equal to x minus 1, 4, 3, and x minus 2. Try to find the values of x that makes matrix A has multiplicative inverse. I hope you solve it, so let's find out our solution. First of all, we need to find the determinant of A. Okay, x minus 1 multiply x minus 2 minus 4 multiply 3. X minus 1 multiply x minus 2 minus 4 multiplied by 3. X minus 1 multiply x minus 2, x times x times negative 2, negative 1 times x, negative 1 times negative 2. X times x is x squared, okay, and negative 1 times negative 2 is 2. X multiply negative 2x multiply negative 2 is negative 2x. Negative 2x minus 1x is negative 3x. Minus 12. Where the 12 come from? Come from 4 multiplied by 3. So our final equation will be x power 2 minus 3x minus 10. So we need to set our function or our equation to equal to 0 to find the values of x that makes our determinant equal to 0, and then we neglect it. Matrix A has inverse if and only if determinant A not equal to 0. So x power 2 minus 3x minus 10 equal to 0. So we factorize to x plus 5 and x minus 2. So I have two solutions. X plus 5 equal to 0 or x minus 2 equal to 0. In case x plus 5 equal to 0, 5 will go to the other side with a negative sign, so x will equal to negative 5. Or x minus 2 equal to 0, in that case, so 2 will go to the other side with the opposite sign, so x will equal to 2. So the values of x or A has inverse if x equal to our difference, negative 5 and 2. Got it, everybody? Okay, let's move on. Example, find the matrix X that satisfy this equation. 2, 1, 3 and 0 multiplied by x would equal to this result. Let me illustrate something. If I told you that a x is equal to c, I need to find x. You said simply, okay, let's move a to the other side by divided. So x will equal to c over a. Correct? Yes, that's what we studied. C over a. But C over a is simply equal, C over a is equal to a C over a. C divided by a is equal to C multiplied by a what? A inverse. A power 2 negative 1. So how to find x? Actually is multiplying this matrix by the inverse of this matrix. Let's find out. Let A become this matrix, this, and C become the result matrix, this. Since AX or A multiplied X equals C, so X will equal C divided by A. C is 2 by 1 matrix multiplied by A inverse is 2 by 2 matrix. Can I multiply C with A? No, I can't. 2 multiply 1 or order 2 times 1. I cannot multiply it by an order 2 by 2. But I can multiply A inverse, that's an order 2 by 2, multiplied by C, that's an order 2 by 1. Why? Because 2 here and 2 here. Okay? Okay. First of all, let's find our inverse matrix A. Determinant 2 multiply 0 minus 3 multiplied by negative 1. 2 multiply 0 minus 3 multiplied by negative 1. So 0 minus 3 will equal to 3. So our inverse matrix is 1 over determinant times. We will replace 0 and 2. So 0 will be here and 2 will be here, and negative 1 will become 1 and 3 will become negative 3. That's what we did, and then we multiply our number here, or our 1 over determinant, times 0. Third times 0 equals 0. Third times 1 equals third. Third times negative 3 is negative 1, and third times 2 is 2 over 3. So our inverse matrix is 0, third, negative 1, and 2 over 3. So we need to multiply A inverse times C. Row times column, row times column. Row times column. 0 multiply 1 is 0. Third multiply 3 is 1. Negative 1 multiply negative 1 is 1. 2 over 3 multiply 3 is 2. 0 plus 1 equal to 1. 1 plus 2 equal to 3. So our X matrix is 1 and 3. Got it? Let's move on. Our last topic in this lesson is solving two equations by using inverse matrix. In Prep 3, we studied our substituting method, our omitting method, solving algebraically two equations in the first degree with two unknown. We got substituting method and omitting method. And previously in our last lesson, determinants, we learned the Cramer's rule. Also, we use it to solve our two equations. Also, we can use another technique called inverse matrix. Let's assume equation 1 will be a1 x plus b1 y equals c1. Equation 2 will be a2x plus b2y equal to c2. We split our solution into three matrices. The first one, or the biggest one, is called coefficient matrix. The second one is called the variable matrix. And the third one is called the result matrix. So, coefficient matrix, variable matrix, and result matrix. So, this column is specific to coefficient of x. This column is specific to coefficient of y. And this matrix remains the same, xy, and this matrix is represented by the result. Let's take an example. Solve each of the following. 2x plus 3y equals 7, x minus y equal to 1. So let's set up our matrices: coefficient matrix, variable matrix, and result matrix. Coefficient matrix, these specific to coefficient of x, these specific to coefficient of y. What's the coefficient of x in the two equations? Coefficient of x here is 2, coefficient of x here is 1. So 2 and 1. Coefficient of y of the first equation is 3, coefficient of y of the second equation is negative 1. So 3 and negative 1. Our variable matrix remain the same, and our result matrix, the first equation has result equal to 7, the second equation has result equal to 1. Then we solve it like the previous example. We need to find the inverse of this matrix and then multiply it by this matrix. Inverse of this matrix, 2 multiply negative 1 minus 3 multiplied by 1. 2 multiply negative 1 is negative 2, minus 3 multiply 1 is 3, negative 2 minus 3 is negative 5. So 1 over a determinant, 1 over negative 5 times. We replace 2 with negative 1 and we change the sign of 3 and 1. Replace 2 with negative 1 like this, and 3 will become negative 3 and 1 will become negative 1. So we multiply negative fifth by this matrix and we will produce this matrix: fifth, negative 3 over 5, another fifth, and negative 2 over 5. So that's our inverse matrix. So we need to multiply this inverse matrix multiplied by C. So our x equal our inverse matrix. This is our inverse matrix, and this our C matrix. Correct? So row times column, row times column. Fifth multiplied by 7 equals 7 over 5. 3 over 5 multiplied by 1 equals 3 over 5. fifth multiplied by 7 equals 7 over 5. Negative 2 over 5 multiplied by 1 equal negative 2 over 5. So our final result will be 2 and 1. So 2 represents our x. So 2 represents our x and 1 represents our y. So our two variables is 2 and 1. X equal to 2 and y equal to 1. I hope you all understand, and if you need any questions, and I mean any questions, please let me know. Thank you, thank you, thank you.